Bismillahirrahmanirrahim. Dr. Sarfrazli here from University of Education, Faisalabad campus. Subject title is Introduction to Riemannian Geometry. Our course code is Math 4129, Semester 8. Okay. Today's topic is arc length. What is arc length? Mathematically, the arc length of a curve starting from a point R0 is the function st and given by st is equal to integral limiting from t naught to t magnitude of r prime of u du. Mean if we have a position vector r of t at a point starting from point t naught and up to any variation t, so our limit become t naught to t, in this one t naught to t, and taking integral of this we get the arc length. Okay, there are some questions, few questions of this. Find the arc length of a logarithmic sequoia. R of t is equal to e power kt cos t e power kt sin t. We solve it here. Given that R of t is equal to this one, and we take and here this prime denotes the first order derivative of this equation. A position vector, this r prime of t is equal to dr over dt. Actually, this is a tangent is equal to minus derivative of this first term. This is e power kt or cos t. Applying the product rule on this first element. First term is e power minus kt sin t, or derivative of cos t is minus sin t, plus cos t is as it is, and e power kt is differentiated. Answer become k e power kt, comma. There is second term e power kt sin t, so we get the derivative of this term e power kt cos t plus k e power kt sin t. Actually, if I call it, this is a first coordinate, mean this is a term of x and this is a term of y. So if we write in vector notation, this term becomes e power kt cos t I plus e power kt sin t j. So here we take a derivative of this one. First order derivative r prime is equal to this one. Now there is a magnitude of this tangent vector, this derivative, and this square of this term e power k 2 kt and k cos t minus sin t plus e power 2 kt, this one, and taking square, this term is common from both terms. This one e power 2 kt e power 2 kt, when we take common outside of the square root, so it become e power kt, and when we apply the square on these two terms and simplify, we get k square plus 1. Okay, and then the arc length is a formula we have. S of t is equal to t naught t r prime of u du. Thus S of t is equal to our initial point is a 0 and up to t, limit is this one. So e power k u k square plus 1 square root du is equal to implies name. Uh, we have a term k square plus 1. This is a constant term, and here we remain with e power k u du, taking integral and applying the limit. So we have answer k square plus 1 over k e power kt minus 1. So the arc length of this position vector r of u is equal to this one. Now, question number 2. There is some different question. Find the arc length as a function of theta along the uh, epicycloid. R of theta is equal to this one. Here are three terms. First term is R naught plus R cos theta minus R cos theta, R naught R over R theta. Second term R naught plus R sin theta minus R sin into this one. And third term is 0. And we have to find and calculate arc length when R naught is equal to 4, R is equal to 2, and theta is equal to 5. So first of all, we write it as is given r of theta is equal to this term, and taking first order derivative with respect to theta. So in this term, r naught plus r is constant. Derivative of cos theta is a minus sin theta. And similarly, in this term, r naught plus this one, all terms are constant. So we take a derivative r naught r over this one. Their derivative of cos is sine, and derivative of angle is r naught r over r, and this term and this r will be cancelled with this one. In next step we'll do this. And similarly, the derivative of r naught plus r sin theta derivative is cos theta, and again minus r sin theta r naught plus r theta, and last term is 0, so it remains 0. So we get this derivative. Now taking the norm magnitude of this r prime theta, taking the square of first term plus second term. So we get r prime theta is equal to r naught plus r2 minus cos into this one, or when we simplify it is a half angle identity. Actually this term become when we take 2 common, this term remain 1 minus cos theta, and 1 minus cos theta uh, whose half angle formula become sine r naught to r into theta. Okay, now for the arc length s theta is equal to, now our parameter is changed. S theta is equal to t naught t r prime theta d theta. This is our general formula. In previous question it was u, and in this question we have it is theta. So s theta is equal to 2r naught this one, and angle this term is constant with this one. So r naught to r theta d theta is equal to, we get a derivative sin theta integral is cos theta. So substituting the limit theta terms from 0 to t 0 to theta. So our limit is from 0 to theta. So we get 4 r naught plus r or this one and this one. So this is this term. This term is our arc length. Now, following the conditions given in this question, this is our main arc length. Substituting r naught is equal to 4, r is equal to 2, theta is equal to 5 as given. So s theta is equal to, when we put here r naught plus r, this term becomes 6 and this term becomes 4. This 4 is cancelled with this one, and this r is again 2. So cos, and but simplifying this term we get minus 24 units. Why this unit? Mean as arc length is a length, so it must be in some units. Mean feet, meter, centimeter, whatever which is used. So as it is length, so we get 24 units is answer. Negative just to note the direction of the arc length. Now there are some questions for you guys. Find the arc length of the following questions. First question is circular helix r of t is equal to r cos t, r sin t, ht, where r is greater than 0, h greater than 0, for 0 less than t less than 10. So here we have a limit from 0 to 10. And R is positive. Why it is positive? Because it is a radius, and radius must be positive, or there must be exist a radius, so it must be positive. Same, H is greater than 0. There must be a number H which must be positive, otherwise this term or this direction shows negative, which is not possible. Okay, and second question, R of t is equal to, this is a general question, to cos hyperbole of 3t minus 2 sine hyperbole of 3t 60. One thing more. In previous question, we have, uh, in previous two questions, we have uh, a position vector in two dimensions, two coordinates, as we have I and j components. Now we have three components, but no problem. It must be solved just like this one, previous question. And third question is again same. R of t is equal to 2 lambda, lambda square, lambda, log of lambda. Lambda is greater than 0 between the points p 2 1 0 and q 4 4 log of 2. Okay, our next topic is tangent, normal, binormal vectors. Let we have a curve. This curve, let we have this curve. This curve, we call this is R of t. This curve is R of t. Let we have this point. We fix here is this point like P. A line which passes through by touching one point of the curve is a tangent. We denote is T of t, and a point which is cutting this tangent, this line and perpendicular to tangent is a normal, and a vector which is perpendicular to normal is a binormal. This one is binormal, and this point is a tangent point. At one point there is only one tangent point. And mathematically we explain them. For a curve R of t, we have the following definition. The unit tangent vector of R of t is uh, R prime of t over R prime of t magnitude. And the unit normal vector of R of t is n of t is equal to tangent derivative of tangent over tangent magnitude. And the binormal vector is tangent vector multiplied by mean cross product with normal vector. So binormal vector is tangent with cross product of normal vector. Okay, the plane spanned by the vector t and n of t and containing r of t is called oscillating plane. Again, the plane spanned by vectors t, mean from tangent vector and normal vector, and containing the curve r of t is called oscillating plane. The same plane is also spanned by r prime of t and r double prime of t. Okay, the plane spanned by n of t and b of t mean a plane which is spanned by a normal vector and binormal vector is called normal plane. And as a remarks, tangent, normal, and binormal are pairwise orthogonal unit vectors. What mean by pairwise? Mean tangent and normal are orthogonal, normal and binormal are orthogonal, and same. If we change the no. Next is from the previous. velocity and acceleration. How we define velocity? How we define acceleration? Let this is a curve. This is a curve. We have this curve, and this curve is denoted by r of t. If this is a tangent line, if a point passing by this moving on this curve and left the curve from this point and make a tangent to it, it is passed by this one. So this line becomes tangent, or this is derivative, or this is a velocity vector, and this is a normal vector. And if this point is moved from here to this side, then it is acceleration of this equation, uh, acceleration of the point moving on this curve. Okay, mathematically given a curve r of t in r cube, if we have three-dimensional vector space, velocity vector is v of t is equal to r prime. T mean derivative of position vector with respect to time, or any parameter which we are using. Mainly we are using r prime, r and t. So velocity vector is v of t is equal to r prime t. And speed, what is different between velocity and speed? Speed is the absolute value, velocity value. And what is acceleration? It is the second order derivative of the position vector. Or this one, r double prime is equal to a n of t plus a t, t n of t. Okay, next, tangential components. In the previous, this a n of t is a normal component. This a of t is a tangential component. Tangential component is a of t is equal to v prime t, or derivative. This one is equal to t of t dot r double prime is equal to now substituting the value of t of t, which is r prime over r magnitude with dot multiplying with dot r double prime dot r prime over r prime magnitude is a tangential component. This is tangential component. Mean a of t is equal to this one, and normal component is equal to v square dot k, which is a kappa, is equal to the v square, as we have v square previously, r prime uh, cross r double prime t over r prime. Okay, unit principal norm. If we have a curve, this one c is a curve, and this is a point p. This vector is called tangent vector, and on this point p, a line which is a perpendicular to this normal is a normal vector n. A vector perpendicular to tangent at p is called the normal, is called the unit principal norm at p, and it is denoted by n, this one, where the straight line passing through p on curve c and parallel to unit principal normal, mean this principal normal, is called principal normal line at that point p. This on this point p, this is principal normal. Okay, now there are some practice questions. Solve for the unit tangent, normal and binormal vectors, and also we can find tangential components and normal components for these questions. First three questions are same as we have solved for arc length. So we solve these three questions for unit tangent, normal, binormal, tangential components, and normal components. And on next page, we have a simple question for question 4 and 5. Find the tangent line to the vector function at the given point. R of t is equal to this term at t is equal to -1. Mean there is a limiting case at t is equal to -1. And R of t is equal to this one. Although here is written we have you just find a tangent line, but in a paper anything can be asked to you. For example, for this question may be called find normal vector function, unit normal or binormal or tangential component or normal component. And same is questions here. For problem 6 to 7, find the unit normal and binormal vectors for the given vector functions. These are just uh, for your practice questions. Uh, this exponential function is given, and this r of t is equal to this one. In this term, we have three. In question 4 and 5, we have limits. Mean after the solution of the question, whatever we have to find, we substitute the limit at the end. So I think you you understand. It's the end of the lecture number 9.